Hello everyone, hope you are doing well. This is Shankar. In this video, I will explain about future, FUTURE, future interface in multithreading. So, by using this future interface, we can achieve the blocking mechanism. So, in last video, we are discussed about thread pools or executor framework. By using executor framework, we can achieve the asynchronous communication. So, while using the executor framework, I want to block the thread until its execution is completed. So, for that, we can use the future interface, right? So but after that in future, like a future will be there, right? Top of that, compatibility feature will be there that will support blocking and non-blocking mechanism. That that is I will explain in next video. In this video I am explaining about future, FUTURE, future interface in multi-threading. So by using this we can achieve the blocking mechanism, right? So it is not a sketch video, it is continuation video of multi-threading playlist. This playlist I will provide in description of this video. So let's get started this video. So let's create a one class, assume like a feature test. So future future test. Select the main method, finish. So I will add put some bullet points based on bullet points, future related, some Azure framework plus future related code I can develop and I can call get method to block the current thread. Remaining threads are will wait until current thread is execution is completed. So some node points here. Some node points. Node post point is thread pools. Thread pools run multiple threads. Multiple threads without creating new ones every time. Without creating new ones every time. So thread pools. What are thread pools are there? So some of the thread pools I can add single single thread pool, single thread pool, fixed fixed thread pool, catched catched thread pool, scheduled scheduled thread pool, scheduled thread pool. It is some more are there. So I am ignoring. Right now I am ignoring remaining. So second point. So we have a future interface is there. Future interface dot get method. So it will blocks blocks the calling thread. Blocks the calling thread and waits for the result. Wait for the result. Wait for the result. So third point, future does not handle exceptions. In compatibility future we have the exception methods. Some methods are there, those methods can handle the exceptions, but while using future dot get does not handle exceptions. We need to use try and catch manually, right? You must you must catch them when calling future dot get method. Future dot get method. These are the 3 points very very important about the future interface. Mostly 2 and 3 points are mostly important. This first point is related to thread pools or executor framework. So one time I will repeat the 3 points. Next I will develop some piece of code. Thread pools run multiple threads without creating new ones every time. So some of thread pools are single thread pool, fixed thread pool, catcher thread pool, scheduled thread pool. So future. So now future interface explanation second point onwards. Future dot get method blocks the calling thread and waits for the result. Future does not handle exceptions. You must catch them when calling future dot get method. So explanation 3 point is done, right? Let's start the development code. While we are developed executor framework, we are selected like fixed thread pool, we are passing the one number, right? Like 3 threads like that. So now executors dot new fixed thread pool 3. Last time we are done like this. It will return the executor service equal to. So this is way done, right? In thread pools like this way done. So I am commenting this. So I will use different way. So executors dot new fixed thread pool by using CPU cores. We can it will create the threads like 4 threads or 8 threads based on the CPU cores. So runtime dot get runtime dot available processors. So now let's copy this, control V. Let's add a command here. So for example, on a 4-core CPU. Suppose assume like I am using a 4-core CPU. Then creates 4 threads. So each core CPU have one thread. 4-core CPU, 4 threads. Right? So suppose on a 8-core CPU. Suppose we are using a 8-core CPU. So creates 8 threads. 8 threads. So it will be creates dynamically. This will create the threads dynamically based on the cores available in the your computer or laptop. See available processor. It will return the int. Return the number of processor available in the Java which one mission. Right? So now we are third pool we are created. Now next if you want to add another command here, so creates thread pool based on number of CPU cores. Number of CPU cores creates thread pool based on number of CPU cores. After that, we need to submit the task. Submit a callable task. So why callable not the runnable? May you can doubt because of so runnable have run method it will return nothing. So callable have call it will return some object or some string like that. So I am passing like submit method will be there that contains overloaded methods. I will show dot submit callable runnable. So callable runnable, right? So I am choosing the runnable here. I am choosing the callable runnable also returning the future only, not the void here. But if you compare callable runnable have run method, it is void method. Callable has call method, it will return the string. But if you see submit callable runnable, both are returning the future. Some result it will be returning. So I am choosing the callable. So I have also added one video like callable vs runnable. Please watch that video as well. So now submit a callable task, right? So service dot submit. Let's add a lambda. So let's add a lambda expression here. So it will return, right? Return. So let's create one private method. Suppose it's like I am doing some addition operation. Addition operation. Suppose int a comma int b. So return a plus b. Here. So suppose some static values pass like 50 comma 10 comma 50. semicolon. So this is only single line, right? These brackets are optional. So let's remove it. Let's remove this as well. Return also not required. That's it. Once this program is successfully run and executed, then I can add some more lines. I can use brackets return as well here. Now what it will return? Future. Future of integer, right? Copy this. Future of integer. Future, right? Control Shift O for future interface import. If you want to add here, future is a interface in Java dot which package Java dot util dot concurrent package, right? So now after that we need to call get method. Get method meant for the blocking mechanism. See, these are the there. These are the methods are available in future. Get so is cancelled is done. I will show get method and is done both. Now get what it will return. See on handle exceptions type exceptions. I said right. So future does not handle exceptions. You must catch them when calling future.get method. Right? And future.get method blocks the calling thread and waits for the result. So now let's add try. We need to handle catch suppose exception e dot print stack state. If you any loggers are there, you can also add. And if you want any custom exceptions, you can add like your class extended with runtime exception is called custom exception, right? So it will return the integer. Suppose it is a value, right? We are getting result value. So let's add a command blocks until thread completes. Blocks until thread completes, then result, then return result. So it is very important. Blocks until thread completes, then return result. Feature dot get. So it will blocks until thread completes, then return result, then return result. So some more comments here. This starts a background thread. This starts a background thread. Background thread. This starts a background thread. Blocks until thread result is available until thread result is available. So blocks until blocks until thread result is available. See, it is very important. Blocks until thread completes are blocks until thread result is available. This starts a background thread. So one thread is completed, then it will return the result, right? So after that, so let's add system.out.println. System.out.println. Suppose like a assume like it is a result. So result value, it will print the result. So why catch block? Let's add a command required because of required because future interface does not does not handle exceptions manually because does not handle exceptions manually, right? So after that, still let's run. After that, I will add some more code until let's run until run a Java application. So result is 60. See, it is still not stopped. it is still in like execution mode, like kind of listening kind of. So now we need to thread pools. We are using the thread pool. We need to shut down the thread pools. For that, service dot shut down. Let's add a command here. Must shut down the thread pool. Must shut down the thread pool. Let's check. Run a Java application. So result. See, there is no red color. So this is one. So here we are using callable, right? So let's add the brackets this time. Let's add the brackets this time. Control X, Control V. So return. So instead of direct return, let's cut suppose integer addition. So we are storing in one variable. After that, we are returning. See, this submit in submit we are choosing the callable. Callable. It will return some result. So I am using return to I am using return. I am returning the result. Whatever add method it will giving, I am returning. So add method is a static method. We can also call like this class name dot class name dot. This is also valid. We can also do. So here is done. I will show is done. Future dot some methods are there. I will show is done. So it will return the boolean. This thread is completed or not. So we are checking this thread is completed or not. So now one command I can add here. Now the task is already completed here. So then only we will get result, right? After completion of only then only we will get the result. So now the task is already completed. So it is completed because get waited for it. So it is completed. Get future dot get, it is a blocking mechanism, right? So it is a blocking mechanism, right? If you want, let's add another command. It is blocking mechanism. It is blocking mechanism. So it is a blocking mechanism. So now let's run. Let's check Java application true. So so we are getting true. That means this task is completed. So let's copy these two lines. So if we add these two lines, so here let's check. After get call only, I am pasted. So after get call only, I am pasted the is done. True. Okay. Control X. B for the get call. I am checking this task is completed or not. So it will be false. See, false result true. So once we are receiving the return available, once result is available, it is telling the this task is completed. So right. So in this video, we are successfully understand feature explanation in multi-threading and why like how this is blocking mechanism by using feature interval how we can achieve blocking mechanism. Next video we will explain about compatibility feature what to achieve asynchronous communication non-blocking. Okay, I will repeat one more time. Thread pools run multiple threads without creating new ones every time. Single thread pool, fixed thread pool, capture thread pool, schedule thread pool. Feature.get method blocks the calling thread and waits for the result. Feature does not handle exceptions. You must catch them when calling feature.get method. So what we have done here, we are created thread pool by using executor service. So and I said pick it up the number of thread based on the CPU cores available in my system. If you are doing your system, so submitting a task. So now I'm calling executor service reference variable dot submit method. It is multiple overloaded methods are there. It will accept one for the callable as a parameter, one for the runnable as a parameter. Now I am choosing callable as a parameter. Both are returning the future, right? So I have created one task. This is the addition operation is a task. Suppose addition operation. This is the one operation. This is a task. I have created a one task, and I have created a one task submitted to the executor service. So after that, so it will return the future interface. Future it will be returning. So I'm checking is done before calling future dot get. I am checking is already done. We will get false. It is not yet completed. Is completed. Is not yet completed. What it will do? Future dot get blocks until thread completes. Then return result. This starts a background thread. Blocks until thread result is available. It is blocking mechanism. Okay, right? Once this is that is completed, it will return the result. I am printing the result. So I am telling why try catch is required. If I will compare feature and compatibility feature, then compatibility feature have some methods for the exception handling. But in future there is no method. So required because feature does not handle exceptions manually. But compatibility feature will handle the exceptions, but feature will not handle exceptions. Right? That's why we need to handle. We need to mention the try and catch. Now the task is already completed because get waited for it. So get method is waited. Get method. Get method is get method waited for it. Waited and the task is completed. I'm checking the status is completed. Yes, it is completed. So we are using the thread pools concept. We need to set down manually. Right? Thank you for watching. For more videos, please subscribe to this YouTube channel.